Okay, well that's always a good day, golf and physics.
Well, except for doing workouts.
Okay, let's go into the last section. Only two conceptual questions. 10 and 11. 10 says, a number of light bulbs are to be connected to a single electrical outlet. Will the bulbs provide more brightness if they are connected in series or parallel, and why? So let me sketch this. We have two options. I'll do just a few bulbs. Bulbs, remember, are a circle with an X in it. So there's option 1. Better make option 2 a little smaller. And I think it says the same single electrical outlet. So what voltage would that be? That? If it's an outlet, 120 volts. Yeah, you might have read it, and it's not on the test, but it's good to know. Also, since that is alternating current, so going back and forth, it's going to be, that's the symbol for it rather than our battery symbol. That's a DC symbol. Now let's make this a little bit smaller. Or, option 2, we could do those in parallel. Okay. And the question is, which one of those is going to provide more brightness? And why? Why parallel circuit?
Just a guess.
Yes, Scott.
Because in a series, doesn't it lose voltage and go to the wire?
Okay, so if we have 120,
Current stays the same.
current has to stay the same. There's no place it can go, else it can go. If you've got current jumping around out of light bulbs in your house, you've got trouble. So current's the same, but you're right on the right track with that losing voltage. Yes, Dave? So as Skylar had said, in a series circuit, these are going to lose some voltage through each one. What do we know? So if we have 5 bulbs and 120 volts, that means each one would drop 24 volts as we go around. So it would have 24 volts across the 2 edges. How much did these have across each? 120 volts. Because that's the same all the way down. So 120 volts. They all have the same resistance R. That means this one's going to have a lot more, 5 times the amount of current going through it, which means a lot brighter bulb. And only 5, it's 5 times because I have 5 volts. Yes, Matt?
So, if it had a large amount of voltage and like the same amount of current, would it still be brighter though?
So if this were 600 volts with 5 bulbs, it would be the same as 120 volts with 5 bulbs in parallel. Because then each of these would drop 1/5 of that, which is 120 volts. But you'd need a much higher voltage. Not to mention the fact that, what happens if that bulb blows out?
Christmas lights.
Right. No light. What happens if this bulb goes out?
The rest still work.
The rest still work. That's handy. I like that.
That's the parallel.
So does the first light shine brighter than all the other ones?
No, these would all be equal. So the electrons, the electric field that pushes the electrons through this is almost instantaneous. It's almost as fast as the speed of light. So any adjustments that it needs to make are going to be instantaneous, aside from the warming up the bulb will change stuff a little bit. But that means any changes in this circuit are going to be instantaneous. So it's not a drop, a drop, a drop, a drop.
Isn't it losing voltage?
losing voltage. Well, the same number of electrons would flow through the whole part of the circuit, and that just determines how much energy is lost in each part of it. It's not like, oh, now the electrons have less energy, so they're pushed less hard. No, they're all pushed the same with the same force. It's just that each of these is losing a certain amount of the energy. Same here. It's just that each of these is losing 120 volts of energy. Each of these would be 24 volts. Yeah.
So with the series, each one would be the same brightness, but just less than the
Right, but much less than in a parallel. Yeah, Zach? Oh, okay. You're contorted strangely then. That's not a lot better. Good.
So if you had a long enough circuit, would the electron ever run out of charge?
Nope, electrons always have exactly the same charge. They always lose that amount of energy no matter how big the circuit is. The more bulbs you have, the less voltage each bulb would get in its turn, and so the less brightly it would burn. Yes. What? Last question. Yes.
So if there was one where the voltage was equal to the, like, coulombs or something?
No, voltage isn't measured in coulombs. Voltage is measured in joules per coulomb.
So electron can't lose its amount of energy?
No. Yes, it can lose energy. No, it cannot lose charge.
It can't lose all its energy?
Well, if it went to absolute zero, it would. Number 11. A car has two headlights. The filament of one burns out. However, the other headlight stays on. Draw a circuit diagram that shows how the lights are connected to the battery. So how are they connected? It must be parallel. So that's how they're connected.
So just make a simple parallel circuit.
Yeah. So this is appropriate for that one. That's a good symbol for the bulb. Appropriate symbol.
Is it 100? No.
It would not. It's probably 12 volts for a car. Most,
12 volts.
and it'd be a battery. Yep. So you'd change that. I'll change that up just to have it here.
Just take out 0.
Most of a car works on 12 volts. That's what the battery is.